Lesson 29, simultaneous equations. We will be able to solve simultaneous equations. Now, this is the next logical step away from literal equations, is to move to simultaneous equations. This week is going to be spent all about dealing with simultaneous equations. So by the end of this week, you should be really confident in how to solve them in multiple ways. Let's look at today's fact. Today's fact is the probability of being born on February 29th is, really quickly, I'll do this for you. This is particularly interesting because this year is a leap year. And leap years only come every 4 years. It's every year that's divisible by 4, and 20 is divisible by 4. So today's a leap year, except it doesn't work with years that are also divisible by 100. And that'll be, it's just a weird rule. Now, the probability of being born on February 29th, most people would then say, oh, well, it's just 1 out of 366. 1 day out of the year, so therefore it's 1. But the problem is this. The probability of you being born on February 29th is not 1 out of 366, because that's the probability of you being born on February 29th if you know that you were born in a year with a leap year. Because there's 4 years, what you've got to do is you've got to say, well, it's actually the probability 1 out of 365 plus 365 plus 365 plus 366. That's the total probability, because you have to say, well, what is the probability that out of all the days in a 4-year ratio, you were born on the one day that is a leap year? Not only are you born in a leap year, but you're also born on a leap year day. So that's, that's the probability in total of being born on the 29th of February. Which means the probability comes out to be 1 in 1461, which is very, very, it's going to be about 0.01. It's going to be about 0.1%. And yeah, I don't know anyone born on a leap year on February 29th. I would love to meet someone born on February 29th, but I have not. If you have met someone born on February 29th or know someone, put it in the chat. The rule, people often say, so the bad thing about them is they only get a proper birthday every 4 years. That doesn't mean that they're only going to be, a lot of people then say, oh, that means that a 16-year-old person could only be 4 years old. It's like, well, that's not how it works. They've still been alive for 16 years. It's just that only had 4 birthdays. So I feel like they got ripped off. But yeah, anyway, that's February 29th facts. Let's talk about simultaneous equations now. Simultaneous equations, we'll be able to solve them. So where have we come from? We've just come from this idea of literal equations. So going back here, literal equations are dealing with 2 variables equaling a value. And then what we did was we dealt with transposing, is manipulating equations to change what's going to be the subject or not. So that's building up how to deal with equations which have got 2 variables in them. Then what we did was we developed equations. We actually created equations from 2 variables. We actually said, okay, 20a plus 12c, we actually, or whatever, sorry, xy. We actually created variables. Okay, we actually created these little equations for us to solve. But I guess the real question comes into that we want to ask is, well, can you solve a literal equation? And that's what we're going to talk about. Before we get to that, I really quickly want to start with, this is the plan for this week. I'm intending to try and get 3 I and J done today. We've got a fair bit of stuff to get through this morning, so we're going to see how we go, but that's my intended plan. I want to try and look at 3K and 3L on Wednesday, And then on Friday, we're going to be doing revisions. I'm going to I would like to do the tests on algebra next week, because this is the last topic. So we're probably going to do that next Tuesday, but I'll just do the same thing I did with the financial math test, make these tests available all day. You guys just need to log on, do the test, and then you're done. If you guys want to use that whole morning period on Tuesday to revise, then I will be available for you guys during that whole period for you guys to ask questions. Now, you guys might be looking at this right now and saying, wow, that's a lot of work. But I want you guys to think that's actually not the case. The reason that that's not the case is 3i is 2 questions. 3k is 2 questions. Those two are very, very, very short. Like pretty much we've only got 2 exercises left. 3j and 3l. 3i and k, pretty much you can knock those over in about 5 minutes. So don't stress too much about those 2. And we're going to show you how to tackle those in a sec. But yeah, so that's going to be the plan. If there are any issues with that, if any confusions or whatever, let me know in the chat, or say out loud now, or you can just send me an email later on. Otherwise, I'm going to move on. We good? I'm going to take that resounding silences. Yeah, we're good. Let's keep going. I want to show you this. This is a literal equation. A plus B equals 10. Now, just because, pardon me, can someone give me a solution to this equation? Specifically, is it a solution?
10 minus b equals a.
Yeah, 10 minus b equals a. But that's not a solution. That's just that's just transposing it to make a the subject. I want a solution. Can someone give me a solution?
Then I don't know.
All right, I'll start us off. Let's go with the solution. Easy solution I can think of. A equals 1, B equals 9. Who can give me another solution? All right. Chat says A equals 2, B equals 8. A equals 5, and B also equals 5. Janae, I don't think that Andrew and Janae, both of those aren't going to work, because if you think about this, right? -5 minus 5 is going to be -10, not 10. And then same with Adri, 9 take away 1 is going to equal 8, not 10. And yep, 6 and 4 works. Seven and 3. Are those all the combinations, guys? So you might think, all right, that's it. They're all the possible solutions. But again, if you start to think about it, you start to see that that's not all the possible solutions. What's this? That one works. A equals 11, B equals -1. 11 plus -1 equals 10. Who can give me another one where then one of the numbers is larger than 10? A equals -5, B equals 15. Good. We've got Michelle coming in. A equals -15. B equals 25. And we'll go with Richard. A equals 21. B equals -11. Now I want to do one more different way that you could answer this question. What if I told you A was 4.5? What's B going to be? If A equals 4.5, what's B going to be? No, because 4.5 plus 4.5, Rochung is going to be 9. 5.5. What that means is that we've got a whole list of extra types of equations. We could have A equals 9.2 and B equals 0.8. So here's my question then for you. How many possible solutions are there to this equation? Too many. There is an infinite amount of solutions. I always like to get students to this point because I guess people often think, oh, they go 1, 2, 3, 4, 1, 2, 5, 4, 3. You know, that's it. They think they get to the end of here. They think those are the 5 possible solutions, but that's not the case. There's also all of these ones where one of the numbers is bigger than 10. There are all these ones where the numbers are between 1 and 10. They're still between 0 and 10. You know what? One of the ones we did forget, by the way. I'm going to slot this in down the bottom. A equals 10. B equals 0. You know, there's so many different solutions. There are an infinite amount of solutions. There are an infinite amount of solutions between 0 and 10. There's an infinite amount of solutions where A is more than 10. A could be any number. But I guess what I want to show you guys is this. Now we're going to show you guys, well, what that means is that we can't actually find a solution. That's all right, Ewan, don't worry about it. Just try and get as much of this as you can. What you miss out on, I'll put online later on. There's an infinite amount of solutions. And so, honestly, we can't solve this because there's so many different ways. What we can do is we can rearrange a problem to make it so that we can make a formula quite easily. And if you look, every single one of these will work in this formula, but it's still not really making a solution. We don't know exactly what A is and what B is. The reason for that is we need more information. What I'm going to do now is I'm going to introduce this here. A minus B equals 2. Now this is what we would refer to as more information. A minus B equals 2. Now if I've got A minus B equals 2, I could go for a whole list of extra, extra formulas. A equals 2, B equals 0. A equals 3, B equals 1. I could go A equals 4, B equals 2. We go A equals 4.5, B equals 3.5. I could go A equals 6, B equals 4. I could go A equals 7, B equals 5. We could go all the way up to A equals 11, B equals 9. And I could keep going. Again, for this one, there is another infinite set of solutions. But why these are called simultaneous equations is if these two equations occur together, and let's just say these both describe something in the world. They both describe, I don't know, maybe they both describe the amount of people that can attend a meeting. Maybe they both represent the amount of money it costs to buy something. If these both represent the same thing, then what you end up with is this situation here. There happens to be a formula, a set of equations that it works for both of those. When you start to get two simultaneous equations, what you end up doing is you end up cutting the infinite down to the finite. When you say that two equations are related, they're simultaneous, they occur at the same time, then suddenly you can't have every single formula. This A equals 1, B equals 9, that works for the first one, but it doesn't work for the second one, because if A was 1, 1 take away 9 is -8, not 2. The only one that works for both the first one and the second one is A equals 6, B equals 4. That works for both of those two ideas here. And that's why we refer to these as simultaneous equations. When these two equations occur at the same time, these two literal equations occur at the same time, we actually can then establish that there must be a solution, and not just a solution, a unique solution, one solution. And I like to start with this slide because it sort of gives people an idea of this is what a simultaneous equation is. This is what it does. It takes the infinite amount of solutions that you could get and narrows it down to just one. Why is it just specifically this one? Because this solution is the only one that ticks box A and ticks box B. That's why. So what does this look like when we start to examine this a bit further? What are some of the other properties? I will point out that I want to look at these two things here just for a second. Honestly, these are not always solvable. Okay? These are not always solvable. If I take these two examples here, 3a take away 2b equals 9, 6a equals 4b plus 18. Okay? Now, let's say that we look at some, let's say we look at some examples here. I'm going to see if I can figure this out on my own. If, let's say, if A was 4, so that'd be 12 minus 2b equals 9, and therefore B must equal 1.5. Okay. A equals 4, B equals 1.5 happens to be a solution to the above equation. Okay. There are, again, another infinite amount of solutions. That just happens to be one of them. Another one might be we'll go with A equals 5, B equals, and 3 times 5 is 15, 15, take away 6, so therefore B equals 3. There's another solution to the above equation. Now, this time, we've also been given another equation here. Now, we can use this equation to then check to see if these solutions work in this equation. If this is like this one, the previous one, there should only be one equation that works. So we can test a few of them. If I went 6 times 4 equals 4 times 1.5 plus 18. 6 times 4 is 24 equals 4 times 1.5 happens to be 6 plus 18. 24 equals 24. Hey, we found a solution to both of those. Great, cool, we're done. But I want to show you the problem here. What if I did this? 6 times 5 equals 4 times 3 plus 18. Okay, well, 30 equals 12 plus 18. 30 equals 30. Oh, cool. We found two solutions, so they're not unique. Now, you might be asking yourself, okay, why is this happening? There's supposed to only be one solution. The reason that this doesn't work, if you're very, very smart, you picked up on it, you might know why this doesn't work. If you don't know why this doesn't work, I can change this equation to be 3a plus equals 2b plus 9. And I did that by dividing each of these terms by 2. And then now you can sort of say, hey, this looks a bit similar. If I now subtract 2b from both sides, I actually end up with 3 take away 2b equals 9. These two look different, but they are the same equation. And so therefore, everything that works in this equation will also work in this equation. These are not simultaneous equations. And the reason these are not simultaneous because they are the same equation. And you can probably see that I could just pick any solution that I want. And because of the same equation, if it works on the one on the left, it will by definition work on the one on the right. So I can't use this to work out if these are simultaneous, to work out a solution. I want you to compare that to these ones here. And these ones here, these two equations, a plus b equals 10 and a minus b equals 2, they are not the same equation. I can't just multiply or divide or manipulate that first equation to get to that second one. They're completely different equations, which is why there is a unique solution. Now, I don't expect you guys to do this, to write down every single solution and then cross-reference it. There are shortcuts. Those shortcuts include these three methods. Pardon me, I'm just putting it in close. Graphically, substitution and elimination. Now, those are the three ways to solve a simultaneous equation, or a pair of simultaneous equations. And we're going to explore each of those today. I'm going to start with graphically, and then we're going to build up to substitution and elimination. And then by the end of it, we're going to probably have a quick talk about, out of these two, which one's better. I want to point one last thing out before I start to show you how to solve these things, just because I find this interesting. If I give you, and then we have whatever, b minus whatever. Notice how that there are, this is just a little bit of a start point. Notice how we've got, here we've got two unknowns. So therefore we need two equations. Okay, just because I want to show you guys this, I thought this might be interesting. If you have three unknowns, a plus b plus c equals 12, you need three equations. You can't just have a plus b minus c equals 8. You need more than one. You could have something like 2c equals a. You don't need to have the b and everything, but you need to have three separate equations. If you had four variables, you would need four equations. Just, it's a bit interesting. We're only ever going to stick, and all of these would be simultaneous equations. We're only going to stick with 2 and 2. I mean, we could do three equations, but we're only going to stick with 2 and 2 because otherwise it's just going to get like a fair bit more complicated. You guys do, by the end of this topic, you will have the maths ability to solve these. You will be able to solve these, but we're not going to ask you to do them. Okay, let's start with graphically. Now with graphically, obviously I don't really fully expect you to draw this picture. I'm just going to show you guys this. Graphically, we've got here two solutions, two equations. One is that y equals 2x plus 5. Okay. The other one is y equals negative 3x. Now, those two equations are, again, two simultaneous equations. Now, when you have two simultaneous equations, that if you plot both of those equations, what you're doing when you plot these is you're actually doing the exact same thing we did here. You are writing down every single solution. Here's a solution to y equals negative 3x, 0, 0. Here's another solution to y equals negative 3x. 1, negative 3. Here's another solution, 2, negative 6. These are all of the solutions to y equals negative 3x. And that means that this line here are all the solutions to 2x plus y equals 2x plus 5. So when I graph these, I see this intersection. That intersection there represents the point where a solution for the first one is equal to a solution to the second one. So if I want to solve these two simultaneous equations, I've just got to say, well, x equals negative 1, y equals 3. And that is a solution that will work for both of those two equations. You can check if you want. If you check, you can just go 3 equals 2 times negative 1 plus 5. 3 equals 3. Tick. 3 equals negative 3 times negative 1. 3 equals 3. Tick. But essentially, this is how you find the answers to something using the intersection. Okay? But I don't actually expect you guys to do this all the time. I don't expect you guys to be able to do this by plotting this graph every single time in your books. That would take way too long. That's not really what I expect you to do. So I'm going to show you something today, something a bit different. For those of you that have got, I'm going to write this down here, just off screen, pardon me. Y equals negative 3x and y equals x minus 8. And what I would like you guys to do is I would like you guys to follow me. I would like you guys to grab a new tab. And I'm going to jump to a new tab. And I'd like you to come along the ride with me. I'm going to open up this new tab. And I would like you to type in desmos.com. You can write it at the top or the bottom. It doesn't really bother me. Desmos.com. That's spelled D-E-S-M-O-S. I'm going to give you guys a second just to catch up. So open up a new tab. If your internet's a bit laggy, a bit, you can't do both at the same time, then just watch me and you can do this later on. But yeah, this is where we're going to go. Once you've done, so I'm going to give you guys a second to make sure everyone gets up to this point. Once you've done that, click this big red button. Now, in this is now a big Cartesian plane. Now, other teachers are teaching their kids to use Graphmatica. I don't like Graphmatica for the simple purpose as you have to download a program. With Desmos.com, in 2 clicks, you guys are already should be looking at the same screen that I am. Now, once you've got to this point, we're going to write down 2 equations. But the first one was y equals negative 3x. Enter. And that will plot a line for you. I'm going to just double check that those are the equations that we wrote down. Yep. The other equation for you to do is y equals x take away 8. And bang, you should have 2 lines. They may be different colors, but you should have 2 lines. Has everyone got something like this on their page? Can I see whether can someone in chat say whether or not they've got this on their page at the moment? Yeah, okay. And who else? Okay, Logan's good too. So just like before, we can now easily see the solution. Now, y equals x take away 8. That means that if x was 8, then y would be 0. If x was 9, y would be 1. So if I grab a look at this equation here, x is 9, y is 1, x is 10, y is 2. If I go all the way down here, I can see there is a point where there is an intersection. That point where that intersection is at -2, 6. I think there might be a way to also search for intersections, but the easiest way is just to click on the points and then it'll tell you 2, -6. That means to solve this problem, we would say x equals 2, y equals -6. This is all you need to know in order to do the first of those 4 topics, 3i. All you're going to do in 3i is open up Desmos and plot the equations. And the first part of 3i is just going to be reading off the answers. The second part is just going to be like plotting them in and then just giving answers straight off the graph. That's what I want you to do. Okay? Get some experience with this. Normally what we would do in class is that I'd also get you guys to get some experience with the CAS calculators. But the CAS calculators that we have at the school are locked up in a room at the school and you guys are all at home. So it's not very useful to you here. So this is how you use Desmos. Okay, you can put just a quick heads up, by the way, it doesn't have to be this nice formula. You could have something like 2y plus 3x equals 5. Pardon me. You can still plot something like that. And we'll still plot over here. Obviously, it's better for you to plot it like this, y equals negative 3x, but yeah, you can plot pretty much anything. Thank you, Andrew. So that's Desmos. And I'm going to go back now to here. And that's, yeah, so after we plotted those two, we found that the answer was y equal x equals 2y equals negative 6. And we got that because that was the point of intersection. So this is all you need to do to solve 3i. Okay, so normally what we would do in class is I would then say, okay guys, work on 3i, and then we're going to come back together in about 20 minutes. I would do that, but I'm not going to do that now because I want to try and get through everything in one session, and then you guys can spend the end of that lesson maybe trying some of the questions out. Now, if we run out of time, I'm going to stop. I'm not going to try and talk over past to get all this done. I just want to see how far I can get. So that's one out of the 3 techniques. That's the graphical solution method. It's pretty easy to do. Either you read it straight off the graph. Remember, you just go, you know, x, okay, is -1, y, okay, is 3, you're done. Or you plot graphs using Desmos. You can also, if you really wanted to be a massive nerd, and sketch both of those graphs and then look at it. But for me, I'm happy if you just use Desmos at the moment because it's just another way. If you want to do Graphmatica because you want to be, you know, cool, Graphmatica is very similar to Desmos, so you shouldn't have much of a difficulty going from one to the other. But I don't really use Graphmatica. It's up to you. We're going to talk about now our second on the list, which is substitution. Substitution is one of the 2 popular methods for solving simultaneous equations. We're going to talk about 3 examples of substitution. 1, 2, 3. Now, and substitution can be challenging for different reasons, but yeah, substitution, if you don't know what it means, it means, you know, swapping in. And that's actually why I've got this picture over here for substitution. You're replacing one thing with another thing. Pardon me. I guess sneeze again. Sorry. Oh man, I got something in my nose. Oh, Jesus. Okay, let's go. Thank you. So let's go have a look at these 2 equations here. 5 take away 2x and 3x take away 2y equals 4. Sweetheart, move. Wait. Wait. Can you give me a tissue? Can you give me a tissue? Sorry. So when I've got these 2 equations here, this first one is in terms of y. What that means is in substitution, in this second one, I've got 3x take away 2y. No, my screen. So I can actually replace this y in this equation with this part here. Because ultimately what I'm doing is I'm just saying, okay, I've got 3x minus 2 5, take away 2x equals 4. I'm just saying that this section here is y, and I've already told you what y is. Now, by the way, I will point out that some teachers, and I usually do this as well, will number these. We're going to call this equation 1. I'm going to call this equation 2. And this is what happens when you substitute 1 into 2. Now that I've substituted this in, the advantage of this is that I only have x's. I don't have y's anymore. So now I've gone from having 2 variables down to only having 1. So if I now expand this guy here, 3x minus 2 times 5 is going to be 10. And then negative 2 times negative 2 is going to be plus 4x equals 4. Guys, guarantee you this is where you'll make mistakes. If you've got a negative coefficient, people always forget to multiply the negative coefficient by the negative coefficient to make a positive coefficient. Be careful. Now that I've got 3x and a 4x, I can combine those two things together. 3x plus 4x is going to give us 7x, take away 10. And then I'm going to get 7x equals 14, which means that x, come on, x equals 2. And I will just, obviously, for most of you guys, you got that I added 10 to both sides to cancel that, and divided both sides by 7 to cancel out that. But if you didn't, those are what we did. Now, that's not the answer yet, though, because that's only halfway done. We haven't actually worked out what y is. So to do that, I'm going to substitute x equals 2 into equation 1. Okay. What is that going to look like? Y equals 5 minus, instead of writing 2x minus 2x, I'm going to write minus 2 times 2. 5 minus 4 equals 1. Y equals 1. So, and you can then then that's pretty much it. X equals 2, y equals 1. But what I will do is just an extra thing. And yes, if you've got extra time left over at the end of the test, or if you've got extra time, you can usually do this. And I would strongly suggest that you do this. It's just to double check your answers. Let's just take equation 2. Let's substitute x equals 2 and y equals 1 into equation 2, just to check that it works. So that means we're going to end up with 3 times 2 minus 2 times 1 equals 4. That's going to be 6 minus 2 equals 4, which gives us 4 equals 4. Hey, what do you know? It works. Great. That's how substitution works in its most basic form. Are there any questions about what I've done here? Or are we clear about what's going on here? Or do you guys want me to go back over something? Let me know if we can move on just in chat. Otherwise, I'll give you guys a second. Can I move on? Yep. Okay. Now, next up, more substitution. Now, with this substitution here, what we're going to do is we're going to solve this by something called end-on-end substitution. Now, Pretty much this is the same type of substitution I just showed you. And there's probably a technical name for it, but this is what I call it. We've got two equations here. Y equals x plus 5 and y equals negative 3x plus 9. But what's the advantage is that they're both in terms of y. Now that means that this would be a great candidate for graphing, for doing graphically. We could actually solve this pretty easily if we put this into Desmos. But let's see how we would do it algebraically. How you do this algebraically is I refer to this as end on end because literally you can put these equations end on end. What do I mean by that? Let's take this first equation. X plus 5 equals y. Yep, that's the same thing. But we also know that y is equal to negative 3x plus 9. So if I cover up this first part, no, I can't. If I cover up this first part, then you can see there's the first equation. If I cover up this second part, there's the first equation. Now, if they both have y as their equal sign, if they both equal y, I can actually just cancel this out. X minus 5 equals negative 3x plus 9. And that's why I refer to it as end on end. Because essentially you're just pushing those two equations together. And you just connect them like pretty much like Lego pieces. And then you, once they're connected like Lego pieces, you just solve them. We've got x minus 5 equals negative 3x. What should I do first? Can someone in the chat tell me, or you can say out loud, what should I do first here?
Sir,
Yeah,
the equation is x plus 5, not x minus 5.
thanks for the save. Thank you. What should I do first? That's anyone, by the way, not just value. What should I do first? What's the first step? Or else I can just quickly go, oh, no, someone's given me an answer. Minus 5. We could minus 5. You know what, Michelle? We'll do minus 5. We'll see what happens. It's minus 5 from both sides. Cancels out the minus 5 here. We minus 5 from both sides. That gets us x equals negative 3x. 9 minus 5 is going to give us plus 4. What are we going to do now? And then, yeah, we're going to add 3x as being our second thing here. Now, Michelle, you're not wrong here. You actually are correct. You need to add 3x to both sides. I would always add the 3x first. The reason is I just find it a lot better to get the algebra out of the way so that you know what side the algebra is on. If I add 3x first, if I add 3x, it's going to give me 4x equals 4, which is just going to mean x equals 1. So I always tell students the first thing you should do is move. The first thing you should do is move the pronumeral. But I guess what we've sort of shown here is you don't have to move the pronumeral. You can do it in whatever order you want, as long as you care. But yeah, I would always prefer to move the pronumeral because then I know what side the pronumeral is going to end up on. That's x equals 1. That doesn't give us y though. Substituting substituting x equals 1 into equation 1 gives you y equals 1 plus 5 equals 6. Y equals 6. You can also put that into the second one, and you'll still get y equals 6. That's how we can solve it. We could check one of these if we wanted to, but I'm a bit lazy and I can't really be bothered. So how do you know when to use end on end? Well, it's pretty obvious when to use end on end, because you'll have, they will both be the same. They'll both be the same pronumeral. Same pronumeral as subject or as the topic of the equation. They're both equal to y. Y equals 4x plus 5. Y equals negative 3x plus 9. If you had something like x equals 2y plus 5 and x equals 8 minus 3y, then yeah, you could do the same thing for this situation here. But we're not going to, yeah, but that's another sort of side point. So there's two types of substitution so far. Firstly, just straight substitution, swapping it in. The second one is end on end, which is still substitution because you're replacing this y. You're replacing this y with the x plus 5 and the y negative 3x plus 9. There's sort of one type of extra type, which is called substitution with rearranging. Now, this is a rare one that you wouldn't normally do. In fact, there are a lot of other better ways to solve. There are better ways to solve this problem than what I'm going to show you. But I'm going to show you just so that we know that it is doable. I'm going to warn you though, it will get ugly. But you know, that's okay. You know, you can't make an omelet without scrambling, breaking a few eggs. Now, straight away, why wouldn't I use substitution for this method? Because there's no easy way to make it y equals something or x equals something. They all have coefficients that aren't 1. So I would straight away not use substitution for this equation. But if you're going to twist my arm and force me to use substitution, then I guess I'll do it. Let's take 1. In equation 1, we're going to do 2y we're going to take equation 1 and we're going to change it. So I'm actually going to write down this one. I'm going to write down, that's what I usually do. Modify equation 1. 2y equals 11 minus 3x. I've moved this 3x to the other side. Now, if I then take that and I write down y equals 11 minus 3x divided by 2. The reason that I've done that, well, is I've just divided both sides by 2. And that's cancel that out. This here I'm going to call equation 3. Now, unlike these other ones where the y was x plus 5 or y was 5 take away 2x, this guy is a bit chunky. It's going to be a bit difficult to substitute into an equation. But we can substitute it into an equation. Let's go substitute equation 3 into equation 2. What are we going to get? 2x plus 3 times 11 minus 3x all over 2 equals 4. And now you guys can see, oh, that looks ugly. If you guys are thinking, oh, I don't want to deal with that, then yeah, you are sharing the same point as me. There are so many easier ways to do this problem, and yet we find ourselves doing the most difficult way. Is it still possible to do? Yes, because it's still mathematically viable. We can still solve this. 2x plus, let's expand this. we're going to have 33 minus 9x all over 2 equals 4. Okay. Now at this point, what I would do is something a bit drastic. I'm going to multiply everything by 2. Now that's going to cancel this, but I need to be careful because I still need to multiply this one by 2. Okay? Because remember, when I'm canceling by multiplying by 2, it would normally cancel everything. But because I've got 2x plus this, I need to be careful. So that's going to give me 4x plus 33 minus 9x equals 8. Okay, getting there. What should I do? You know what? I'm going to stop here. What should I do now? Can someone tell me what I should do now? Nine x take 4x. Thank you, Rochang. You're correct. We're going to get rid of this. Well, not 9x take 4x. You mean 4x take 9x. Please tell me. No, yeah. Because we've got a negative 9x here. Look. To get rid of this negative 9x, we're just going to go 4x take away 9x is going to be negative 5x plus 33 equals 8. Now, we're getting close. What do I need to do now to this equation? Someone let me know. What's the next step? Next step is to minus 33. Thank you. Minus 33 from both sides. 8 take away 33 is going to give us, I'm actually going to use the calculator because I'm going to make a mistake if I'm not careful. Negative 25. Should you guys be able to do this in your head? Of course. Is there anything wrong with using a calculator? No. I use the calculator only when I know that I could make a mistake. And I don't want to make a mistake, especially when I've done all of this work just to get to last step. Divide both by negative 5. X equals 5. Oh, that was a lot of effort. Now, as I said, there are easier ways to solve this problem. I'm just trying to show you that even when you need to, you can still use substitution. It just means you just got to rearrange the formula. Now, the other side of the coin here is then to say, well, what about y? Well, we could substitute y into the first equation or the second equation. Doesn't really matter. Let's substitute. Let x equal 5, and let's put this into equation 1. 3 times 5 plus 2y equals 11. 15 plus 2y equals 11. 2y equals, if I subtract 15 from both sides. Oh, crap. 11 take away 15 is going to be negative 6, negative 4. Yes. I'm actually going to double check just because I know that I'm going to make a mistake. Oh, I was right. Therefore, y equals negative 2. And there is our answer. Hoi. And yeah, you can double check this. if you wanted to. 2 times, well, I'll just double check this over here really quickly. 2 times 5 plus 3 times -2 equals 4. It's going to be 10 minus 6 equals 4. 4 equals 4. Everyone's happy. Now, as I said, this is an extreme example. I would actually not have come anywhere near this with substitution. Instead, I would use elimination to solve this, because I think elimination would be much faster and quicker and involve less of this, you know, BS. So, yeah, would I have done this? No. Is this mathematically correct? Yes. Could you do this? Yes, if you wanted to. But this is one of the reasons why, at the very end of this lesson, I usually spend time talking about which method you should use. Yes, you could use substitution for this method, but it's for this solving these problems. But that would not be the optimal solution. That would not be the best idea to use. So I've got about 15 minutes left. I've got 2 equations for elimination. I might be able to get through them both, but I'm not sure. If I don't, I'll stop, but that's okay. Let's go have a look at elimination. Elimination is the third of the methods. So graphically, substitution, elimination, the idea is we're going to take 2 equations, we're going to add them together. Now you can add equations together, that's fine. Sometimes you might want to just double check to see, can you just add an equation together? Let's take 2 simple equations up here in the top right. 3 plus 2 equals 5. That's an equation. It works. We'll go with 10 minus 2 equals 8. That's another equation. If I add those 2 equations together, I'm going to have 10 plus 3 plus 2 minus 2 equals 5 plus 8. 10 plus 3 is 13, plus 2 is 15, minus 2 is 13. 5 plus 8 is 13. So ultimately what we've done is this 2 here cancels out. We end up with 10 plus 3 equals 5 plus 8, which is 13. So you can add equations together. That's fine. And it should make sense. If this side is equal to this side, if the left is equal to the right, then it won't matter if you add another equation where the left is equal to the right, because you're just adding both sides. So why is this an advantage for us? Well, because if you look at this equation here, I've got a plus y and a minus y. If this is equation 1 and this is equation 2, if I take equation 1 plus equation 2, what that means is I'm going to take x plus 2x, which is going to be, actually I might do it over here. I'm going to take x plus 2x, which is going to give us 3x. Positive y minus y, well, that's going to give me 0. So I'm actually not going to write anything. 0y equals 3 plus -9, which is going to be -6. 3x equals -6. If I divide both sides by 3, then that's going to give me x equals -2. Why can't they all be this simple? If x equals -2, substitute, let's do that over here, substitute x equals -2 into equation 1. So again, we still need to use substituting, but I guess it's a little bit simpler here. -2 plus y equals 3. Adding 2 to both sides gives us y equals 5. Done. Now, you might look at these types of equations here and you might say, oh, but sir, could you just use substitution? And you know what? This top one here wouldn't be too bad of a candidate for substitution because it's already got a coefficient here of y as 1. But I'm not actually going to, I wouldn't actually, but because I'm trying to show you guys how to use elimination, I would not be using, and this is actually a good candidate for elimination, just because it's got a plus y and a minus y. It's just so easy to add these two equations together. Now, what if the world was not that simple? What if it was a little bit more challenging? Okay. What if you had something like this? 3x plus 2y and 2x plus 3y. Notice how it's the same equation that we just did. But now, because we're using elimination, this is going to be so much easier to do. I'm so excited to do this with the proper method. Now, the reason why elimination is the best method to use in this situation is because we don't have to do too much manipulation. Now, in order to do elimination properly, we need to make sure that we eliminate something. So what we're going to do is we're going to eliminate one of these by multiplying them by -2. Okay, we're going to multiply them. We're going to try and make the coefficients the same. So let's see if we can get rid of the x's. So we've got 3x at the top here. If I multiply this whole equation by 2, then I'm going to have, if I go 2 times equation 1, that's going to give us 6x plus 4y equals 22. Now, if I then take, and the reason I chose 2 is because it's going to make 6. The highest common factor of 3, the lowest common factor of 3 and 2 is 6. So let's go 3 times equation 2. That's going to give us, you know what? Let's make it -3 times equation 2. That's going to give us -6x. -3 times 3 is going to be -9y. And -3 times 4 is going to be -12. Now I can add these two equations together. If I add these two equations together, I'm going to end up with these two are going to, these two are going to cancel. So I'm actually going to end up with 4y take away 9y. It's going to be -5y equals 22 plus -12 is going to be 10. Which means that y is going to be -2. Holy crap. Can I get some appreciation for how much easier this is compared to this?
Good job, sir. Good job.
Thank you, Bayu. Thanks for the appreciation. I appreciate it. That means a lot. I think it's a lot easier. You guys actually might disagree. You actually might be like, I actually like substitution better. But I think I don't have to deal with multiple term fractions. It's just a quick and easy thing like this. I can then just take this, and just to wrap this up, we'll just quickly put this, we'll substitute y equals -2 into equation 1. So 3x take away, no, plus 2 times -2 equals 11. 2 times -2 is -4. Okay. Add 4 to both sides. 3x equals 15. X equals 5 both sides by 3, x equals 5. So that gives us two equations here, the two variables here, y equals -2, x equals 5. This requires a lot less work than the other one. And that's because we dealt with it like this. The trick with elimination after manipulation is you need to make sure that they are the same coefficient. One's a +6, one's a -6. How did I know to do that? Well, I just multiply the first one. You look for the lowest common multiple. And the lowest common multiple in this of 2 and 3 is 6. And that's why I wanted to make sure that I got to 6. So I multiply the top one by 2, the bottom one by -3. Why -3 and not just 3? Because I want to make sure that when I add these together, that they cancel. And they did. They canceled down to give me that here. So I guess, okay, and we've got 5 minutes left. So I've got enough time to get through that last slide. This last slide is, there's no real actual working out here. There's just some things here. When should you choose each of them? So substitution, go nuts on substitution it's great if you have the pronumeral as the subject. Y equals 4x plus 1. That's your pronumeral, then you really should be going with substitution. If you're lucky though, if you still have a coefficients that are 1, it's okay. So for example, 3x plus 1y, that can easily be turned into y equals 8 minus 3x pretty easily to then solve, okay, with this equation here as well. So they're okay with that. When is it a good idea to use elimination instead? This is great if both equations have the same coefficient. If you're lucky and both of them have the same coefficient, hey, grab a look, they're both 2y, you should go elimination. Or if they're just in the same form. What do I mean by same form? X, Y, number. X, Y, number. That's the same form. That means it's going to be very easy for us to then, sure, we may have to multiply by a common factor, but elimination is going to be a bit easier. So essentially, whenever I see just a y on its own or just an x on its own, I will go straight to substitution. But the second I start to see mostly numbers like 2s and 3s and 4s, that's when I would go elimination. This is a bad example because you see you've got -x here. That could be done as elimination, as substitution step. But yeah, see how down the bottom here, I've got 2s and 3s and 2s and 4s and 3s. Yeah, I'm not going to try and do crazy substitutions here. I'm just going to find a way that I could add those two things together and cancel them out. I probably multiply just so to show you what I would do. I probably multiply this one by 3. And I'll probably multiply this one by 2 because that's going to give me 6y equals 3 times 17. Jesus, why did I try? 3 times 17. Why did I even bother? 51. And then this one, if I multiply this by 2, 8x plus 6y equals -14. 6y, -6y, those are going to cancel. Everything's going to come out nicely. All of these, by the way, if you want to, you can come back and solve them. I've actually made sure that each of these 3 equations are solvable, and they do have solutions. I wanted to do that just in case I got carried away. I thought, hey, I might as well solve these. Each of those is solvable. So if you want to do them later on, you can. But that's the idea. When you use each of them, whenever you've got a 1, a coefficient of 1, I would go straight for substitution. When you have weird coefficients, I go elimination.